Welcome back, guys. So now today I will discuss Leetcode weekly contest 281. So this is the first question. So those who have done it, or so because this is a very basic question, so those who have done it can move ahead and by using the timestamps that I have added. They can go to the next question. So yeah, now I will explain these questions. In this question, now I will explain this question. Like in this question, we are given a positive integer num, and we have to return all those positive integers less than or equal to num whose digit sums are even. So, and also now let's see what are the constraints. It is for beginners only. So now let's see how we are approaching to the problem. First, we'll see the constraints. The constraints are like num can be maximum 1000. So what we can think of is like we can go on each and every number and check the sum of its digit. So what would be its time complexity? Its time complexity would be n log n. Why? Uh, because what we'll do, we'll iterate from 1000. Each and every number will go. Okay. And then for each number, we'll calculate the sum of digits. So what will be the time complexity? Let's say for 1000 we are calculating. It would be how we'll calculate the sum of the digits. Like we'll divide the number by 10 again and again until it becomes 0. And we'll also modulo it subsequently. And then we'll calculate modulo it by 10. Then we'll get the digit. We'll get the digit. Like I will show you in the code. Like it is the digit sum. Like any like the sum of digits we are calculating here. Like initially our value is 0 of answer. Like the value of digit sum. Then when n is not equal to 0, as I told, till then we'll divide it by 10. And then what will be the digits? N modulo 10 would be the digit. Okay, because we are each and every time we are extracting a digit. So we are summing it also, and we are returning the sum. And we'll check the sum whether it's even or not. If it's even, we'll calculate in our result. Why? Because we have to give all the integers. We have to count the number of integers which are less than equal to num and whose digit sums are even. So we are checking the digit sum and we are returning. Okay, and it's time and we are returning those numbers who have even digit sum. Like the time complexity that I told is n log n. Why? Because we are iterating till 1 to num. Okay, so n it is there. Let's suppose num is n only. Okay, so n times we are iterating, and also for each time we are also doing operations. Which operations? These operations, like calculating their digits. So it would be log n. Why? Because like you can see for 1000 you will need, first you will divide by 10, then it would, first you will take modulo by 10 is 0, then divide by 10 it is 100 modulo 0, divide by 10 it is 10 modulo 0, divide by 10 it is 1 modulo 0. Now no number till is 0 will take the digits in consideration. So these are the digits that we have counted. As you can see, like it is like in 4 times, like for 1000 also 4 times we had to run. So it was log base, like log n only, log n for each iteration, and this is n. So it's upper bound. That is only that we tell in complexity. So it is n log n. Okay, now let's discuss the second question. Yes, now I will discuss the second question. The question is like we are given a head pointer, and what the question says is like there are certain amount of zeros in between the linked list, and also the starting value is also 0 and the ending value is also 0. What we have to do is like in between those zeros, the values that are coming, we have to sum them up, and put as a single node. So this is what we have to do. Now let's understand it by example. Let's suppose this is the linked list we are being given. So what we have to do, in between two zeros, we have to see how many nodes are there. We have to sum them up. What would be the sum? 3 plus 1, 4. And we have to make a linked list of those values which are not 0. Which means here 4 will come, here 5, 4, 9, and 2, 11. Here 11 will come. Okay, so two nodes we have formed aggregately, and also we have to remove zeros in our final answer. So answer would be 4 and 11. That would be a linked list that we have to return. Okay, as you can see in this example. Similarly, in this example, you can see 1, 3, 4 we have to return. 1, 3. Yes, this is the linked list that we have to return. So now let's see our approach. So approach is a bit simple only. So let's see the approach. So let's suppose this is a linked list. Values are 0, 1, 2, 0, 1, and again 0. Okay, so let's suppose this is our example. So what we'll do, we'll just simply see if our current value is 0, then we have to start a new sum. Okay, let's suppose we are maintaining the previous sum. Okay, so we are maintaining it, and then we are moving ahead. Previous sum is uh, 0 only initially, then we move at this position, then our previous sum becomes plus 1, because it is not a 0 value, so we'll add the number. It is 2 plus 2, value becomes 3. Then we have encountered a 0. What we have to do, if we have anything, any sum which is not 0 prior to this value, prior to this 0th node, then what we have to do, we have to make a new linked list and insert 3 value to it. Okay, now again we'll move forward. This is 0, so also we'll make our sum pointer to 0. Previous sum equal to 0. Now again we'll start the summing. Okay, so now this is 1 plus 1, so previous sum becomes 1, again 0. So now previous sum will be set to 0, and another node will construct sum 1. So still here the sum was 1. So this is how we have created our linked list. Now let's see the code only, because I think approach is as easy as we can see. So this is my code. What I have done is, like, I have created another list, and then I am putting the sum values into that list, because I have to return linked list at the end. Okay, so like pointer to the list. So this is how I have done it. Initial sum is 0, then if pointer value is 0, and if previous sum is not 0, then I have to make a new node with the sum equal to the sum that I have collected until now, and then I'll check whether it is the first node in the list that we have to return, or there are already the lists available. So I can, if they are already available, then I can attach the current node to the previous node. Okay, this is how I have attached it. And if it is the first node, then we can create it as our head. Okay, and since we have encountered a 0 value, our current sum we have to do is 0, and if the value is not 0, then we have to sum, as I told earlier. Similarly, we have to move until our linked list is exhausted. This is how we have calculated the answer. We are returning the pointer to our head. Yes, so now let's discuss the third question. We have to construct string with repeat limit, which means we are given a string s, and we have to construct a new string which is a repeat limited string using the characters of the string s that we have been given, such that no letter appears more than the repeat limit times in a row. Okay, and also it is not compulsory to use all the characters. And what we have to do is we have to return the lexicographically largest string that we can make, and we have to return that. And what does that mean? That means that if you, lexicographical order means in dictionary order. So we have to construct a string such that it would be the last among all the possible strings that we could have generated. We have to generate such a string which would be last in dictionary. If we have arranged all the possible strings that we could have generated in lexicographical order, which means in dictionary order, then the last word is what we are looking for. That's the word that we have to return. Okay, so now let's discuss the approach. This approach is also easy. Okay, so now let's see the constraints also. So as we can see, the constraints are like the string length can be 1 to 10 to the 5. So we can think of like big O of n or somewhat similar to that only, like number of operations we have to do. Like we can get a slight idea, and also this is like very obvious kind of solution in this problem. So what we'll do, since we have to generate lexicographically largest, so what we'll do, first of all we'll check all the, like what basically we are doing is, let's suppose our string is ZACCAC and repeat limit is 2. So what we'll do, first of all we'll reversely sort our string, so it would become this kind of thing. Okay, so now what we'll do, we'll uh, first take the lexicographically largest character, which means Z if Z is there, or Y is in reverse order. Whichever element is first, we'll take that and we'll check whether its consecutive count is greater than 2 or not. If not, then it's okay. Move ahead. We'll take C. Its lexicographical count here is 1, which is less than 2. Okay, no problem. Again C, it's like total count of consecutive C's until now is uh, 2 only. And also see, like Z, we have exhausted Z, that's why we are looking for the next lexicographically largest character, which is C. So we are looking upon that. Here 1 C, no issue. 2 C's, no issue. But if we use third C, then there would be a issue, because repeated number of, like repeat limit is 2 only, and we have third character set as C. So it won't accept that, because three consecutive characters cannot be same, because repeat limit is 2 only. So we cannot put C here. We'll check ahead. We'll check whether any other character is there which we can put. Yes, we have A. Yeah, put A here. So now again the count for A will begin. It is 1, no problem. Now again the lexicographically largest character that we have in our remaining characters, it is C, because 1C we haven't used, so now we'll use C. It's now current um, frequency in consecutive, like it's now its current consecutive frequency is 1 only, so no issues. Less than 2, move ahead. Now all C's are, now what we have left, only 1A, so we can use it. So now we'll use it. Okay, this is how we have generated our answer. So basically it's quite obvious. We'll take the largest, lexicographically largest character, and similarly we'll see if we can put it or not. If we can put, we'll take it. And at the stage, if we reach to a stage where we cannot take it, then we'll see a next character which we can take. We'll put that character, and again we'll start from our character which we have in access, and which is the lexicographically largest. Similar, this is how we are moving ahead. Now let's see the code. So yeah, this is the code. Like, this is the frequency array that I have made. I'm counting like how many times a particular character has come or not. Like, this is how I'm counting. Like frequency array, the frequency of each and every character I'm counting. Then, as I told, you have to sort it reversely. So I have sorted it reversely, the string. This is how I have done it. Like, algorithm is same only. Like, we have to do according to that only. So this is how I have done it. Like, I have reverse sorted it, and then what I'm doing, I am checking whether this character is possible to put or not. Like, because it might happen that A might have been used. Let's suppose another example, Z Z Z C C C A A. Okay, so now let's see. We'll take Z. Now let's see how we are doing. We'll take this Z. We cannot take this Z, so C will take now Z again. And now the lexicographical chart is CC. Um, Now we can take A. So let's suppose if there was one more C, then what we would have done? Uh, C would have come here. Okay. So what we have to check each and every time, because this character we might have used it earlier. So we have to check whether the current element is available to put here or not. So we are checking. I am checking it here whether we have this in our bank or not. Like, if we have available, if the current character, then we can move ahead. And also we'll increase the frequency. Like, this is, I'm counting the whether the current element, how many times this current element have occurred. okay, in consecutive fashion. And similarly, these are some corner cases. Like I am also checking, like this is the main condition. Like if the repeat limit is r, and if greater than that, our current becomes, which means the consecutive length of our current character becomes greater than r. Then what we have to do, we cannot put that character at this position. So what we'll do, we'll move ahead. Like I'm moving ahead and searching. I'm moving ahead and I'm searching whether is there any other character that I can put. As I have searched, I have found one character. Then what I'll do, I will break from there. Then I will make that character, add that character currently to my list, and again I will start from zero and see for that character, like other, like here as we did ZCC. Then C we could not put, so we'll check for another character. A we could have put, so we put A here. Then again we'll check from C only, okay? Because we have one C remaining to be put in our answer string. So this is how I have done it. You can see the code. Like this is how I have checked whether in ahead is there any character. And also one thing, like why my time complexity is not big of n square, because I'm keeping the record, like till which pointer I have checked. Let's suppose this is C, then I'm checking until I reach that A. I'm checking uh, like for the next time I have to move ahead from that place. Like I don't have to search again this whole space again. I'll move from ahead. Okay, so this is what I have done here, like in K. So similarly, this is a basic idea, same like now you can also implement yourself, but keep this thing in mind. This condition, like till the positions that you have covered, you don't have to cover them once again, like by checking that whether you can take that character or not. So this is a thing that you should inculcate in your code. So this is how I have done it. And if the consecutive length of our current character is less than equal to r, then no problem. We are directly adding it. And also we are checking that whether the frequency of that element is greater than zero or not. Whether, which means whether it is available or not. If it is available, we'll take one and reduce the total number of available. Okay, so this is how I have done the third question. So now let's see the fourth question. Okay, so now let's see the fourth question. So it is like we have to count, like we are given a zero indexed integer array of length n, and also we are given an integer k. And what we have to do is we have to return the number of pairs ij such that num array of I into array of j is divisible by k. So we have to return all such kind of pairs. Okay. So now I think the question is clear. So now I will explain what approach I have used. So yeah, now I'm considering the array as A. So this is the condition that our pairs should satisfy. So we have to count number of such pairs I comma j. Okay. So now this is a bit observation kind of thing. Like what you can say is like let's suppose a number a of I is given. So now what I'm saying is like a of GCD of a of I and k. This is what the number that is useful, and a of I should be kept equal to GCD of a of I comma k. Why I'm saying so? Because the numbers which are significant in these two elements is the numbers that make up k. What I'm saying is like let's suppose k is 50, so which is 2 into 5 into 5. Okay, so now 1 2 might be coming from this element and 1 5 from this element, and one other 5 also from this element. So this is how they are multiplying and they are creating a 50 in this number. Then only it is divisible by k, which is 50. Okay, this is clear, because after multiplying they should contain a factor 50, like they should contain k as a factor. So how they could be making k as a factor is like a of I might be bringing some factors of k, and a of j also might be bringing other factors of k which a might not have. So this is how they are multiplying and they are getting divisible by k. Okay. So now we can say that a of I equal to GCD of a of I comma k. This is only what matters, because let's suppose k is 50 as I mentioned. 1 2 is coming from a of I and 2 5 are coming from a of j. So now let's suppose this number is 6. So would it matter? Like, would the 3 matter in this number? No, because 3 won't help us in making 50, because we cannot do anything from this 3. So why should we take it? Okay, we should remove it and we should say directly that yeah, this a of I is 2 only. No, it's not 6, it's 2 only, because its GCD with k is 2. Okay, so this is how we are replacing each and every number. I have proved also like this is correct only. Why? Because after getting multiplied, they have to make k. So other numbers which do not help in making k are not useful. Okay, so simply we'll make each and every element this. Okay, so now let's see how we'll count. Yes, so now for counting, what we'll do? Uh, what is our range of our GCD? 0 to k. Okay, so not 0. Sorry, 1 to k. Okay, this is the range in which our GCD after taking with k would lie of all elements. And also now let's see the constraints. Also, I forgot to mention that these are less than equal to 10 to the 5. Okay, so what all GCD we can have in this range we can have GCD. Okay, and also what all will be the GCD? They would be definitely the uh, factors of k. Okay, that's divisors of k. Like, they would be able to divide k. It's for sure. Okay, so now let's suppose k has a b c d these as factors. Okay, so now what we are like that those factors wouldn't be that much. Okay, it's clear. Why it's clear? Like, you can see the range is 10 to the 5. So you can also see, like, if you are making factors that if you let's see like this, if you take 220 or 25 times, I think that would exceed 10 to the 5. Okay, so you can see that what I mean is, like, not that many factors would be there. Like, you can prove also, like, you can see, I think not more than like not more than 200 factors you would get. I'm not sure about that. Like, I have calculated also earlier, but now I have forgotten which things I had taken. So it is easily seen that not much factors would be there. So yeah, now I am mentioning my approach. So what I'm doing is, earlier what we did, we counted how many times each of these GCDs have come. We have counted. Like, for 6, our GCD was 2. Similarly, for another number, let's say 14 comes, and for 14 also our GCD would be 2. So similarly, that number will also become 2. So in order to count easily and fastly, we have to calculate this frequency, that how many times 2 has come, so that in one go only all 2 can be counted and we can take them into account. Okay. So I have made a frequency array and I am counting each and every time, each GCD, how many times it has occurred, like each value how many times it has come. I am counting that. Okay, now the approach. Now let's the thing that I was telling, like what I'm counting. So this is what I'm counting in an array. So this is one part. Like, if you are getting confused, keep it in mind that this is the first part. Like, what I have counted, like the frequency of the GCDs. Like, what are the GCDs that I made it earlier? Like, because I converted our array a of I equal to GCD of a of I comma k. So for that, the frequency I have maintained. That is the thing that I have counted. Okay, no issues until now. So yeah, now let's come back. So, and also in between, I mentioned that not that many divisors, you can say, of k would be there. Okay, so what we can do, for each divisor, we'll check. Like let's suppose the divisor are 1, 2, 4, and 5. For 20, let's suppose we are checking. divisors would be 20 and 10 also. Yeah, so these are the let's say factors of 20. A equal to 20 we are considering. So these all GCDs would have come, that's for sure. And I have maintained their frequency here. 1, 2, 4, 5 and 20. Okay. So now what will I do? I will check for every divisors I will go on and I will check. Like for one I will take one and I will check for others. Like I will multiply it by 2. Like is this number divisible by 20? Like 2 into 1, no, not divisible by 20. 1 into 4, not divisible by 20. 1 into 5, not divisible by 20. 1 into 20, yes, divisible by 20. So I will take this whole pair. Like the two elements I have to choose. So one element from this and one element from this. So how many choices do I have? Like this, let's name this array as count. So count of 1 to count of 20. These are the number of elements which would be divisible by k, and their GCD was 1 and 20. So this is how I have these all numbers, these all pairs I have counted in my answer. Now let's see what other pairs would be in our answer. For other pairs, I will make that count there once again. 1, 2, 4, 5 and 20. Yes. And yeah, until now answer plus equal to CNT of 1 into CNT of 20, because on multiplying they would definitely form a k or a multiple of k. Okay, so these are the pairs. Similarly for 2 we will check for 2 whether 2 into 2, 4, no, not divisible by 20. 2 into 4, 8, not divisible by 20. 2 into 5, not divisible by 20. 2 into 20. Okay, sorry, 10 was also there. Here 10. So 2 into 2 not divisible by 20. 2 into 4 not divisible by 20. 2 into 5 not divisible by 20. 2 into 10, yes, divisible by 20. So answer plus CNT of 2 into CNT of 10. And also, will this be a pair 2 into 20? Yes, definitely. So plus CNT of 2 into CNT of 20. Similarly, for 4 also we'll check for 4. 4 into 5, yes, definitely a factor of like a multiple of 20. 4 into 10, these also will be paired. 4 into 20, yes, this also will be paired. Similarly, for 5, 5 into 10, no, they won't be paired. 5 into 20, yes, they would be paired. So this is how I have calculated the sum. Okay, so now all our answer would be covered. So I think that's clear. If not, like you can watch the video again, because I think that would be like this part. You can watch this part of the video again, because I think that would be really beneficial. Why? Because like I mentioned each and everything, and some things might have gone like up and down to you. So like they might have got mixed up. So you can watch the video again like this for this part, and it will make you clear. Like that solution would be clear to you. Now let's see the code. The code is like this is the like I type def. I have already defined long into array, and as I have mentioned, I am maintaining a count array. So I am not modifying AI equal to GCD of AI comma k. Rather than I'm directly, and again then I have to make CNT array. I am not doing that part, and I am directly putting GCD AI comma k, and I'm directly putting that into my frequency. Like I would have, according to my explanation, I would have done this. I should have done this a of I comma k. Then I would have done a of I plus plus. Okay, so these are the same thing only. Then I'm checking if this is a corner case. Like according to my case, if k equal to 1, which means the pairs which are divisible by 1, uh, you have to return those. So each and every pair would be divisible by 1. No issues in that. So n into n minus 1 by 2. because these are the number of pairs that we can make. Okay. Similarly, I have here what I'm doing. I'm counting the divisors, which means like I'm counting that uh, factors of k. Okay, I'm taking into account all the factors. As I told earlier, that I'm counting and I'm storing them into a vector. Then I'm looping over them. Like I'm checking that whether any two of them taken together can they be a multiple of 20. If yes, then I have to take into account the pairs that I can generate from the frequency of those two divisors. Okay, so this is what I am doing. Answer equal to count of div of I into count of div of j. And also, yeah, this is the important thing. Now let's suppose in our previous example, let's suppose 10. So for 10, 10 into 10 is 100, which is also divisible by 20, which means these numbers paired with themselves should also be counted. So how to take that thing into account? So what we have to do? CNT of 10 into CNT of 10 minus 1 by 2, because among themselves also they can form a pair. These are the things that we left earlier. So now I have to add them also. So this I forgot to mention. So yeah, this is another thing that I have to add. Why? Because like they can also be paired among themselves and they can also be a multiple of 20. So that's why we have to consider them also. So that's why if div of I into div of j percent k equal to 0, this is the sum I have done. And why? Because I is not equal to j, that was the case. But if I equal to j, then this condition would be followed if two factors taken together are divisible by k. And as you can see, the loop is starting from j equal to I, which means if I is not equal to j, which means this won't be satisfied in the initial condition. So we'll check here. If possible, then we'll add. Otherwise, we won't. And for j greater than I, then we'll are considering each and every pair, possible pair of divisors, like which can generate k, which can be a multiple of k. So yeah, this is my approach. This is the code that I went wrong. I think maybe wrong I was. So yeah, this is the solution. Easily I am counting and I am returning the answer. So yeah, thank you very much, guys. Okay.